All right, let's dive into some serious AI stuff today, huh? We're really going deep on this Epoch AI report. Can AI scaling continue through 2030?
Yeah, this is a big one. Lots to unpack.
I mean, you know our listeners, always hungry for more AI insights, and this report is like looking into the future, trying
Yeah,
to figure out if this crazy speed of AI development, can it even keep going?
right. Like, is this the limit or just the beginning?
Exactly. And Epoch AI brought the receipts too. We're talking articles, data visualizations, all that good stuff.
They really went all out, didn't they? It's impressive.
They did, and they're not messing around with the big questions either. It's like first page, bam. Can we just keep making AIs bigger and smarter at this rate?
No time wasted. I like it. Gets right to the point.
Right. And to figure that out, they put their focus on four big, what they call potential showstoppers:
Okay, I'm intrigued. Lay it on me.
power, chips, data, and this thing called the latency wall.
Okay, latency wall. That one sounds a little ominous.
Right, we'll get to that. But first, let's talk about the electricity part. The juice. I mean, we all know our phones, laptops, they need power. But these giant AI models, turns out training those things is crazy power hungry.
Oh, yeah. We're not talking about your phone charger here. We're talking gigawatts.
Yeah.
Like, enough to run a whole city.
Whoa, seriously, like AI needs its own power grid.
Well, not exactly. But the report, it doesn't just look at, how much power we can generate in total.
Right.
It digs into how much power our current infrastructure can actually, like, deliver to the data centers where all this AI training happens.
Makes sense.
They use Northern Virginia as an example, biggest data center hub in the U.S.
Right, right, of course. So it's not just about building more power plants, it's about the whole system being able to handle it.
Exactly. Like, you try filling a swimming pool with one of those tiny little cocktail straws, it's not going to work. You need a bigger pipe. Who knew AI would give us infrastructure headaches?
Yeah.
Right?
Let's talk about unintended consequences. Okay, so power, that's one thing. But what about the chips themselves? Everyone's talking about chip shortages these days.
Yeah, it's been a constant headline.
And this report, it goes deep into how those shortages are specifically impacting AI development.
Right, because it's not just about any chip.
Exactly. And turns out it's not even just about making more GPUs overall, it's about super specific processes. One of them is called co-West packaging.
Oh, yeah, I've heard of that. That's a tricky one, right?
It is, we can get into the nitty-gritty of it later, but for now, just know it's a bottleneck.
A big one.
Yeah. And the report makes it clear, even if a company like TSMC, the top chip manufacturer,
Right.
even if they put all their effort into just AI chips, which is unlikely, let's be honest,
Not going to happen.
there's still a speed limit on how fast they can churn these things out.
Supply and demand, man. It's a classic problem, but in a whole new area.
For sure. Okay, so we've got the power situation, we've got the chip conundrum. What's next? It's data, right?
Gotta feed the AI beast somehow.
Right. And we've got mountains of the stuff these days. Everyone's posting everything online, text, images, videos. It's got to be enough to keep these AI models happy, right?
You'd think so, wouldn't you?
Yeah.
But it's not that simple.
Oh, there's always a catch.
Always. And this is where the report goes from interesting to, like, really thought-provoking. It dives into this concept they call data equivalence.
Data equivalence. Okay, I'm listening.
It's basically how much information is truly contained in, say, an image compared to, like, a paragraph of text.
Ah, okay. So it's not all created equal in the AI world. Makes sense. Like a picture's worth 1,000 words, but maybe not 1,000 words of, like, usable data.
Exactly. And then it gets even more complicated when you start thinking about AI that learns from multiple types of data at once. Multimodal AI, they call it.
So text, images, sounds all mixed together.
All of it. It's like baking a cake. You can't just substitute flour for sugar and expect it to turn out the same,
Right? You got to have the right ingredients and the right amounts.
Exactly. And finding the right recipe for multimodal data, that's a big part of the challenge.
Okay, so I'm starting to get a sense of the puzzle here. We've got these AI models with a huge appetite for data.
Insatiable.
But it's not as easy as just dumping everything on the internet into their, like, digital mouths and hoping for the best.
Nope. And that, my friend, brings us to our last hurdle for today.
Yeah.
The mysterious latency wall. Remember that?
Oh, yeah. The one that sounded like something out of Star Trek?
Well, it's based on real-life physics, and it basically boils down to this. Even with crazy fast processors, there's a speed limit on how fast information can actually travel.
Okay.
As AI models get bigger, more complex, they need more and more communication between all those processors, and that communication takes time.
So it's like even if we had all the power, all the processing power in the world, there's still this traffic jam inside the AI's brain.
Yeah, it's like rush hour in there, no matter what. That's the latency wall in a nutshell.
Okay, so we've got these like four horsemen of the AI apocalypse, right? Power, chips, data, the speed of physics itself. It's starting to feel like a recipe for AI disaster.
Well, I wouldn't say it's all doom and gloom. The report does, it lays out these challenges, but it also suggests that by 2030, we could actually see AI models 10,000 times larger than today's most advanced AI.
Hold on. 10,000 times. Are you serious? What would that even look like?
It's hard to even wrap your head around, right? I mean, for perspective, it's like going from a basic calculator like the one you had in school to a supercomputer that can, like, design new drugs and write symphonies.
Okay, that's a serious upgrade.
No joke. It's both exciting and, a little bit terrifying at the same time.
Yeah, exciting and terrifying pretty much sums it up. But let's go back to those roadblocks for a minute. Like, if we actually wanted to hit that 10,000x target, where do we even start?
Well, the report goes deep on each constraint, starting with the power issue. Remember all that talk about gigawatts, AI needing its own energy grid? They get really specific here. Like, they talk about these things called data center campuses. They're these mega complexes dedicated to, training AI.
So like AI gyms where these models pump iron and bulk up on data.
Exactly. And they highlight that data centers using something like 1 to 5 gigawatts of power, those are probably doable by 2030. Even with like our current infrastructure limitations. Just to give you a real-world comparison, that's about on par with that deal Amazon just made, for 960 megawatts of nuclear power for their data centers.
Hold up, nuclear power for AI. Are we talking Skynet here? Should I be worried?
It's not quite that dramatic, but it does highlight the sheer scale of energy we're talking about. These data centers would be absolute behemoths, churning through data, capable of supporting AI training runs that range from, get ready for this, 28 to 329 FLOP.
Okay, pause. Back up. FLOP. Is that like AI jargon for a whole lot of oomph?
Basically, it stands for floating point operations per second, but yeah, oomph works. It's a way to measure an AI's processing power. More FLOP equals a faster, smarter AI.
Got it. More FLOP, more smarts. But how do those data centers actually stack up against what we've got now?
Good question. So GPT-4, one of the most powerful AI models out there right now, it's estimated to be around 2E25 FLOP. We're talking about potentially a tenfold increase in raw computing muscle with these new data centers.
Tenfold. That's mind-blowing. But what about this distributed training thing we touched on earlier? Is that where, like, AI is sharing power across the country?
Bingo. The idea is you tap into multiple energy grids, right? You've got several data centers working together instead of just relying on one massive one.
So instead of one mega AI city, we're talking like a network of smaller AI cities, each with its own power supply.
Exactly. Less strain on a single grid, less chance of a total blackout. And the report says that kind of distributed network, just in the U.S., using what we already have, could potentially handle 2 to 45 gigawatts of power.
That's, what, almost 10 times what's possible with even the biggest single data center.
Yeah, the math checks out. So distributed training could be a real game changer for getting around those power limits. But even with all that potential power, I mean, we can't just magically conjure up power plants overnight, can we?
Right. It's not like we can just plug AI into the sun and call it a day, although that would be pretty cool.
Sign me up. But yeah, the report acknowledges that. They use Northern Virginia. Again, they say even with all the expansions they've got planned there, they're unlikely to go over 10 gigawatts by 2030.
But I thought they were like the biggest data center hub in the U.S. What's the holdup?
They are, but even the big dogs have their limits. It comes down to stability, reliability of the power supply. It's not just about cramming in more data centers. It's about making sure the whole system can actually handle the load. Think about, like, upgrading the electrical system in your house, right? You can't just keep adding more and more appliances without making sure your wiring and your circuits are up to the task.
Yeah, you'll blow a fuse for sure.
Exactly. And that's what we're talking about on a much larger scale here. And, while we're on the subject of infrastructure, the report points out something else that I thought was really interesting. They say a big chunk of AI's future power needs, they might actually come from natural gas.
Wait, natural gas? That doesn't sound very futuristic, does it? I thought we were all about renewables these days.
Me too. But the report highlights this real tension between, needing these massive amounts of power and the U.S. goal of switching to 100% carbon-free energy by 2035.
So classic dilemma, the need for power versus the environmental cost. Are we going to have AI running the world but destroying the planet in the process?
It's a real concern. And the report, it does emphasize that natural gas power plants, they're affordable, they're scalable, they can be built relatively quickly. It might be a way to quickly ramp up power generation to meet this, insatiable demand for AI.
But there's always a but.
It does feel like a step backward, right? Like we're taking two steps forward, one step back.
Right.
It really highlights just how complicated this whole thing is. We're so focused on pushing AI forward, but we also have to think about the resources, the consequences.
And not just for us, but for, the planet, the future.
100%. The decisions we make today about powering the AI revolution, those are going to echo for years to come.
No pressure, right? Okay, so we've covered the power struggle, but what about that other big bottleneck, chip manufacturing? We sort of dipped our toes in earlier, but I feel like there's a lot more to uncover there.
Oh yeah, we're just scratching the surface.
Mm-hmm.
The silicon heart of AI, it's just as complex as the power grid that feeds it.
Okay, so walk me through it. What's the deal with chips?
The report really focuses on TSMC, since they're the world leader, right?
Yeah.
And it's the same story as with power. The demand for these AI chips, it's going through the roof, and they're struggling to keep up.
So even if we had all the electricity in the world, we still couldn't build enough AI brains to actually use it.
That's the problem in a nutshell, yeah. And the report, it breaks it down into two main constraints. Remember CoWoS packaging?
Yeah, the bottleneck within the bottleneck. But this time, remind me what it actually is, please.
Sure. It's the process of combining the actual AI chip to brain, right, with high bandwidth memory, which is essentially its super fast data storage. They get packaged together onto a single unit, and it's that packaging process that's really hard to scale up.
So it's not just about making more chips, it's about putting them together in this very specific, very complicated way.
That's it. And right now, TSMC's CoWoS packaging capacity, this is a huge choke point. Even with the expansions they have in the works, it's going to be incredibly challenging for them to catch up with this insane demand.
Okay, CoWoS packaging check. What was the other constraint? Something about memory, right?
Right, high bandwidth memory or HBM.
Right.
This type of memory, it's crucial for these chips to access and process data super quickly. Think of it like having a super fast internet connection, but for your brain. And just like with the packaging, HBM production is also lagging behind.
Double whammy of production constraints. It's like trying to build a car without wheels and a working engine.
You got it. It's a messy picture. But the report crunches the numbers. They look at TSMC's plans, their track record, all that, and their median projection is that by 2030, TSMC will be able to produce enough chips to support a 9029 FLOP training run.
Okay, back to FLOP. That sounds promising.
It is a massive amount of computing power. But there's a but. A big one.
There's always a but. Hit me with it.
This projection, it's based on some pretty big assumptions.
Like what?
Well, for one, it assumes that AI chip production keeps growing at this crazy rate of 30% to 100% every year. I mean, that's what we've seen recently, but it's a huge if.
For sure. No guarantees in the chip game.
None whatsoever. And even if TSMC hits those numbers, there's still a ton of uncertainty. Their estimates for the number of H100 equivalent GPUs, those are some of the most powerful AI chips out there, by the way. They could actually be used for training by 2030. That range is enormous. We're talking 20 million to 400 million.
That's a huge margin of error. So even the experts are kind of throwing darts at a board when it comes to the chip shortage.
Pretty much. But let's play a game. Hypothetically, we throw caution to the wind, right? We push those constraints to the absolute limit. What happens?
I like where this is going.
So imagine TSMC goes all in, all their production capacity, every single chip they make is a GPU.
Wow, talk about putting all your eggs in one basket.
Right. And we're talking about their most advanced stuff, too, 5 nanometer and smaller nodes.
Mm-hmm.
If they did that, they could potentially reach 130 to 2E31 FLOP by 2030.
So there's hope.
There's a path, but it's a gamble. And even with all the chips and all the power, don't these AI models still need mountains of data to actually learn anything?
Yeah.
We've got all this potential computing power, but what about the fuel?
Right, like building a rocket ship but forgetting the fuel.
Exactly. And that brings us to the next hurdle, data scarcity.
Wait, data scarcity? Seriously. I thought data was the one thing we had plenty of. Everyone and their grandma is posting everything online these days.
True. But there's a difference between the amount of data and the amount of usable data.
Okay, I'm listening.
The rate we're producing data at, It might not be enough to keep up with AI's appetite, especially as these models get bigger. Remember those 10,000x models we were talking about?
Oh yeah, the things are going to be hungry. So how much data are we talking about? Like, is it even possible to collect and process that much information?
Let's break it down, starting with text. The report estimates that the indexed web, so all the text that's publicly available online, it's about 500 trillion words.
500 trillion. That's like more words than are in every book ever written, right?
Way more. It's about 30 times more data than even the largest training data sets that we're using today.
Okay, so 30 times larger. That's got to count for something, right?
It buys us some time for sure. There's this thing called the chinchilla scaling laws, and it basically says you should scale up your model size and your data proportionally. So if we used all the text on the indexed web, we could potentially train models with 30 times more data and 30 times more parameters.
Hold on, parameters. Those are like what did you call them before? The AI knobs and dials.
Exactly. They're the settings inside the model that get tweaked during training. The more parameters, the more complex the model can be.
Got it. More data, smarter AI, but there's always a but.
Always. Even if we used every single word on the entire internet, it would only get us so far. To reach those massive 10,000x models, we need to go beyond text.
Okay, so what else is there? Images, videos. People are uploading millions of those every single day.
You're on the right track. There's a goldmine of data out there beyond text. The report calls it multimodal data, basically, using data from tons of sources, like you said, text, images, videos, all of it. They think this multimodal data could be the key to scaling AI.
So instead of just reading everything, these AI models could also like watch every video and analyze every image.
Exactly. But the challenge is figuring out how to combine all that effectively. How much weight do you give an image versus a paragraph of text? It's like if you were trying to build a house out of wood, bricks, and straw. You need to understand how each material works and how they fit together.
Right. It's not just about throwing everything together and hoping for the best. You need a plan.
Exactly. And the report, they call this the data equivalence problem, figuring out how to make sure different types of data are weighted correctly during training. It's a huge research area right now.
Okay, so multimodal data is promising, but it's not like a magic solution to the data scarcity problem. What else is on the table? What are the AI folks brainstorming?
Well, one idea that's gaining traction is using synthetic data.
Synthetic data. Okay, that just sounds made up. Is that like AI-generated content?
You got it. Using AI to create data to train other AIs. Think of it like AI writing its own textbooks.
Whoa, so AI is not just learning from us, it's starting to teach itself. That's both impressive and a little creepy.
Right. It's a wild concept. And it's early days, but synthetic data could be huge. You could unlock these massive amounts of data that we just don't have otherwise. Imagine, like, generating realistic simulations of anything you can think of. Medical scans, financial data, whatever you need. The possibilities are pretty mind-blowing.
Okay, I can see the appeal, but it's not without its own issues, right?
Exactly. One of the big concerns is something called model collapse. Basically, if we start relying too much on this AI-generated data, the models, they might start to lose their ability to learn from real-world stuff.
Right. It's like feeding a student nothing but practice exams. They might ace the test, but they don't actually understand the material.
Exactly. So it's a potential solution, but we have to be careful. It's all about finding that balance.
Okay, so we've thrown a lot of information at the wall here about the challenges facing AI development. Power, chips, data, it's a lot. Is there any hope that AI scaling can continue at this insane pace, or are we headed for like an AI winter?
I wish I had a crystal ball. I wouldn't be here. I'd be on a beach somewhere.
Right, living the dream.
Seriously. But the truth is, there's no easy answer. This report, it doesn't say yes or no. It's not about predicting the future. It's about understanding the things that will shape it.
Okay, so no easy answers, but at least they're giving us a framework for thinking about the problem.
Exactly. It's nuanced. It makes you think. They say that continued AI scaling is possible, but it's not a guarantee. It depends on a ton of factors, technological advances, economic incentives, and, frankly, the choices that we make as a society.
So it's not just about the tech itself, it's about how we use it, the investments we make.
100%. We're not just along for the ride here. We're the ones holding the map, choosing the destination.
I like that. We're in the driver's seat. So even though the report highlights some pretty big challenges, it's also kind of a hopeful message.
It is. It's a call to action. For researchers, policymakers, business leaders, everyone, really, to think critically about the future we want to build with AI.
So what are the risks? What are the potential rewards? How do we make sure everyone benefits? It's a lot to consider.
It is. Yeah. And on that note, I think it's a good time to move from the can we to the how much will it cost part of the conversation.
Right. Because all this fancy AI doesn't come cheap.
You already know.
All right, let's talk price tag. How much are these AI dreams going to cost us? How's the report? It actually tries to put a number on training one of these future AI models.
Yeah, they do. And spoiler alert, it's not going to be cheap.
I had a feeling. Give it to me straight. What are we talking about here?
Hundreds of billions of dollars.
Potentially hundreds of billions. Okay, that's a lot, even for AI. Break it down for me. What's the cost breakdown on a price tag like that?
So the hardware, right, the data centers, those specialized chips, all the infrastructure, that's a big chunk of it. The report says hardware alone for just one training run on one of these next-gen models, that could be around $200 billion.
200 billion. I need a minute to process that. And that's not even factoring in, like, the electricity bill, right?
Oh, that's just the equipment. Then you've got your ongoing costs, your electricity, maintenance, cooling systems. All that adds up fast.
So let's say I've got a spare $200 billion lying around, and I'm ready to invest in the future of AI. Even then, it's still a question of whether the potential benefits outweigh that insane cost.
It's the billion-dollar question, literally. And the report really emphasizes this idea of return on investment. Just because we can build something doesn't mean we should. We got to be smart about where we invest in AI, make sure we're not just throwing money at a problem without a clear path to, actually solving it.
Don't just spend because you can. Spend with a purpose.
Exactly. They're saying be careful about chasing bigger and bigger AI models without thinking about the practical side of things. It's like building the world's fastest car, but you haven't figured out where you're driving it to, or if you could even afford the gas.
Right. It's all fun and games until you run out of gas on the AI highway.
Yeah.
But this is the tricky part, right? Because unlike investing in, I don't know, the next big social media app or something, the economic impact of all this AI stuff, it's still a big unknown.
Absolutely. We're still figuring out how AI is going to change industries, how it's going to create new opportunities. It's like trying to predict the weather 10 years out. We can make some educated guesses, but there are a lot of factors at play.
So while the potential is huge, and I think we've established it's huge EE, it's still a bit of a gamble. Are they saying we should maybe, like, slow down, hit the pause button until we have a better understanding of the economic landscape?
They don't go that far. They're not saying stop, but maybe shift focus. Keep investing in the fundamental research, absolutely, but we should also be putting more effort into developing practical applications.
So less pie-in-the-sky AI research, more how can we use this to solve real-world problems?
Exactly. It's about bringing AI down to earth, showing people its value in ways they can see and understand. Think about the early days of the internet. It started with these niche applications, a lot of skepticism, but once people saw how it could be used in their everyday lives, that's when things really took off.
So we need those aha moments for AI, the things that make people go, oh, that's how this could actually work.
That's it. Find that sweet spot between pushing the boundaries of what's possible and making sure those advancements actually matter to people.
Okay, we've covered a ton of ground here. Technical challenges, economic realities, the potential environmental impacts of AI. It's a lot to wrap our heads around.
Yeah.
So for our listeners who are still with us, what are the key takeaways from this report? What's the headline?
I think the report is a call to action. It's a reminder that the future of AI isn't some predetermined thing, like it's already written. We're writing it right now with every choice we make.
I like that. The future is not set in stone. So even though this report lays out some serious challenges, it's also a message of, what, empowerment.
Exactly. It calls researchers, policymakers, business leaders, everyone really, to really think about the future we want to build with AI. What are the risks? What are the potential rewards? How do we make sure the benefits of AI are shared by everyone? These are questions we all need to be asking.
It's not just about the technology. It's about our values, our priorities, and how we manage this incredibly powerful tool. It's about making sure AI serves humanity, not the other way around.
Couldn't have said it better myself.
Well, there you have it. Another deep dive into the world of AI in the books. And to our listeners, as always, stay curious, stay informed, and keep asking those tough questions. Until next time.